Good morning. Today we are going to learn the most important part of this lesson, that is basic proportionality theorem. In short, it is said to be BPT, that is basic proportionality theorem, and we'll also learn converse of this basic proportionality theorem and examples on these two. Now we'll start with basic proportionality theorem. The statement of this theorem is if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. This is about statement of this theorem. Now the first step to prove any theorem is to draw proper diagram. Now here we have to draw one triangle and then we have to do some construction according to this statement. Now we'll draw first triangle, any type of triangle, suppose triangle ABC. We'll draw triangle ABC first. This is our triangle ABC. According to our statement, we have drawn triangle ABC. Then we have to draw one line parallel to a side of a triangle. Means we have to draw one line which is parallel to any of these three sides of this triangle. Suppose we have will consider side BC of this triangle, or we'll take side BC of this triangle and we'll draw line which is parallel to side BC. This will draw any line which is parallel to BC. Suppose line L, it is like this, and which will be parallel to side BC. This is the next step of our diagram. Suppose line L is parallel to side BC, means the distance between line L and BC is same everywhere. Line L is parallel to side BC. Now next, line parallel to a side of a triangle intersects the remaining sides in two distinct points. Now this line L intersects the remaining two sides, means first side we have taken as BC and the remaining two sides are side AB and side AC. Now this line L intersects remaining two sides in two distinct points, and these are the two distinct points, and suppose these two points are P and Q. Or we can take D and E also. In your textbook it is P and Q, therefore I have taken P and Q. Now this line L intersects side AB at P and line L intersects side AC at point Q. This is about a diagram. Now then the line divides the sides in the same proportion, means from if to then this part is called given, and the part which comes after then, that this part is to prove. Now next step is to write given. The first step is to draw proper diagram, next step is to write given. Now the part of the statement which comes in between if and then, means this part is given, and the part which comes after then is to prove. Now what is given? Means from diagram also we can write, or you can use statement also. What is given? That is in triangle ABC, in triangle ABC, line L is parallel to side BC. Line L is parallel to side BC. This is given. And one more statement we have to write, that is line L intersects side AB at P and line L intersects side AC at point Q. That is line L intersects side AB and side AC at points P and Q respectively. Line L intersects side AB at P and line L intersects side AC at point Q, means line L intersects side AB and AC at point P and Q respectively. Now the next step is to write to prove. First step is to draw proper diagram, then we have to write given. The next one is to prove. Now what is to prove here? That is the statement which comes after then. Then the line divides the sides in the same proportion. Then the line means line L divides the sides means remaining two sides. The sides means remaining two sides, that is AB and AC. Now line L divides sides AB and AC in the same proportion. This is what to prove. Now because of this line L, this AB or side AB is divided in two parts, that is segment AP and PB. Also line L divides side AC in two parts, that is segment AQ and segment QC. Now we have to prove line L divides segment AB and AC in the same proportion, means we have to prove AP upon PB is equal to AQ upon QC, means all these four segments are in proportion. Means we have to prove AP upon PB, these are the four parts of these two sides, and AQ is equal to AQ upon QC. This is how to prove. See once again, AP upon PB is equal to AQ upon QC. Now to prove this, we have to do one construction. To prove this, we have to do one construction, that is we have to draw or we have to join points P and C, or we have to draw segment PC and segment QB. This is our construction. We have to draw segment PC and segment QB. That is draw segment PC and segment QB. Now the last part of this theorem is the most important part, that is proof. See once again, we have drawn proper diagram, that is triangle ABC. There is one line L which is parallel to one of the side of the triangle, that is side BC. Line L divides side AB at P, line L divides side AC at point Q. And we have to prove AP upon PB is equal to AQ upon QC, and we have constructed or we have drawn segment PC and segment QB. Now we will move towards proof. For that, observe these two triangles, that is triangle APQ, that is this one, and triangle PQB. Observe these two triangles, that is triangle APQ and triangle PQB. Means if you draw these two triangles separately like this, here is your point Q. If you draw these two triangles like this, this is A, here is point Q, and here is B, and here is your P, or here is your P. Observe these triangles, that is triangle APQ and this one. These two triangles are having APQ, and these two triangles are having same height. Means if you draw height of triangle APQ, it will be like this, and if you draw height of triangle PQB, it will be again like this. Means these two triangles are having same heights, and by using previous property, that is if two triangles are having same height, then the ratio of their areas will be equal to ratio of their corresponding bases. I am going to draw same height here also. Observe this triangle APQ. I can draw height like this. Of considering AP as base, I can draw height like this. This is height of triangle APQ. This is height of triangle APQ, that is QP is the height. Sorry, not QP, suppose QR. QR is the height. This is your point P. QR is the height of this triangle. Now observe this triangle, that is triangle PQB. If you consider PB as base of this triangle, then height will be same. That will be on extended part of this PB. That is QR will be the same height for this triangle also. See once again, if you consider this triangle and AP as base, then height will be QR. And if you consider this triangle, that is triangle PQB, and if you consider PB as base, then height will be same, that is QR. Means these two triangles are having same height. These two triangles are having same height, and by using property or previous property, that is, if two triangles are having same height, then the ratio of their areas will be equal to ratio of their corresponding bases. Means we can write area of triangle APQ upon area of triangle PQB is equal to ratio of their corresponding bases, that is AP upon PB. This property we have learned yesterday, that is area of two triangles. If two triangles are having same height, then ratio of their areas will be equal to ratio of their corresponding bases. Means we can write area of triangle APQ upon area of triangle PQB is equal to ratio of their corresponding bases, that is AP upon PB. I am going to write this statement here. That is area of triangle APQ upon area of triangle PQB since these two triangles are having same height, therefore ratio of their areas will be equal to ratio of their corresponding bases, that is AP upon PB. AP upon PB. Suppose this is statement number 1. Statement number 1. Now observe another pair of triangles, that is first triangle will be same like this, that is APQ. And second triangle I am going to change. First triangle is same, that is triangle APQ. And second triangle I am going to change as PQC, that is this one. First pair we have taken this one and this one. Now we will take this as second pair, that is triangle APQ and triangle PQC. Triangle APQ and triangle PQC. Now in these two triangles also, if you consider AQ as base, then height will be, if you consider AQ as base, then height will be like this. Height of this triangle will be like this. And for this triangle also, if you consider QC as base, then height will be again this one, suppose PS. If you consider AQ as base for this triangle, then height will be PS. And for this triangle also, if you consider QC as base, then height will be again PS. Means these two triangles are having same heights. Hence ratio of their areas will be equal to ratio of their corresponding bases. Means we can write area of triangle APQ upon area of triangle PQC is equal to ratio of their corresponding bases, that is AQ upon QC. That will be our statement number 2. That is area of triangle APQ upon area of triangle PQC. PQC is equal to ratio of their corresponding bases, that is AQ upon QC. AQ upon QC. That is statement number 2. And for every statement we have to write proper reason, and same reason for both statements. Therefore I am going to write it once. And what is the reason? That is areas proportionate to bases. Areas proportionate to bases. Or we can write property about areas of ratios of two triangles or triangles with same height, that this is also reason correct. That is areas proportionate to or I am going to write in short, that is triangles with same heights. Triangles with same heights means these are two triangles with same heights, and these are the two triangles also with same heights. Now these are the two pairs. Now we will take another pair. of triangles, that is this one, this yellow color, that is triangle PQB and triangle PQC. I'm going to write these two triangles here again separately. Here is your point P, here is your point Q, B and C. Observe these two triangles, that is triangle PQB and triangle PQC. This one, PQB and PQC. Now for these two triangles, if you consider PQ as base, is it same for these two triangles? PQ, which is base for triangle PQB, and PQ is base for triangle PQC, means these two triangles are having same base, that is side PQ. And what about height of these two triangles? If you consider PQ as base, then height will be like this. This for we have to extend this, height will be like this. And if you consider PQ as base for this triangle, then height will be like this. This is height of first triangle, this is height of second triangle, and since these two are parallel with each other, since line L is parallel with side BC, these two are parallel with each other and the distance between any two parallel lines is same everywhere. Therefore, these two distances will be same again. Means heights of these two triangles are also same, base is already same and heights will be also same. Means these two triangles are having same base and same heights. Hence, ratio of their areas will be equal to 1, or their areas will be same. Observe these two triangles again, that is triangle PQB and triangle PQC. These two triangles are having same base, that is PQ, which is same base, and their heights will be also same. Heights will be also same. Means these two triangles, that is triangle PQB and PQC, are having same base and same heights. Hence their ratio of their areas will be equal to 1, or we can write their areas will be same. Means we can write area of triangle, that is this denominator and this denominator, that is triangle PQB is equal to area of triangle PQC. PQB and PQC, statement number 3, reason for this will be triangles with same base and heights. Triangles with same base and height, these two triangles are having same base and heights. Now observe statement number 1, 2 and 3, that is from 1, 2 and 3. Statement number 1, 2 and 3. Observe left hand sides of 1 and 2. This is left hand side of 1 and this is left hand side of 2. Numerator is same in left hand side, that is area of triangle APQ and area of triangle APQ. Means numerator is same. What about denominator, that is area of triangle PQB and here PQC? Numerator is same and denominator is different, that is PQB and PQC. But in statement number 3, we have got denominators also same, that is PQB equal to PQC, or area of triangle PQB is equal to area of triangle PQC. Means from 1, 2 and 3 we can write these two left hand sides will be same. Numerator is already same and denominators we got same in statement number 3. Therefore, from 1, 2 and 3 we can write left hand side is equal to this left hand side, that is area of triangle APQ upon PQB is equal to area of triangle APQ upon PQC. Left hand sides as it is, area of triangle APQ again upon area of triangle PQC. Means left hand sides I am going to write again, and but same APQ upon PQB, APQ upon PQC, and since left hand sides are same, their right hand sides will be obviously same. Means we can write, I am going to write this last statement here since I have no space on board. Therefore their right hand sides will be same, that is AP upon PB is equal to AQ upon QC. AP upon PB is equal to AQ upon QC, and this was our target, that is AP upon PB is equal to AQ upon QC, and we have reached up to our target, that is AP upon PB is equal to AQ upon QC. Proof is very simple and straightforward. See once again. Statement of this theorem is, if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Now the first step to prove any theorem is to draw proper diagram. We have drawn triangle ABC, and there is one line L which is parallel to one of the sides of the triangle, that is line L is parallel to side BC, and line L divides side AB at P, line L divides side AC at point Q. Means this is given, and we have to prove this line intersects or divides other two sides in the same proportion. Means we have to prove AP upon PB is equal to AQ upon QC. AP upon PB is equal to AQ upon QC. And to prove this, we have constructed two segments. That is, we have drawn two segments, that is segment PC and segment QB. This is our construction. Draw segment PC and segment QB. Proof is very straightforward. In triangle APQ and triangle PQB, these two triangles are having same heights, therefore ratio of their areas will be equal to ratio of their corresponding bases, that is AP upon PB, statement number 1. Taking this pair, that is triangle APQ and PQC, in these two triangles, by using same reason, ratio of their areas will be equal to ratio of their corresponding bases, since triangles with same heights. Statement number 1, statement number 2. Now observe these two triangles, that is the denominators PQB and PQC. PQB and PQC, that is PQB and PQC are having same base and same height, therefore their areas will be same. Statement number 3, that is triangles with same base and heights. Now from 1, 2 and 3, in 1 and 2 numerator is already same, denominators we got same in statement number 3, hence left hand sides of 1 and 2 will be same. Left hand side of 1 is equal to left hand side of 2, and since left hand sides are same, therefore their right hand sides will be also same, that is AP upon PB is equal to AQ upon QC. AP upon PB is equal to AQ upon QC, that is our target. Means we have reached up to our target. This is about basic proportionality theorem. If you want screenshot, then take, or otherwise write it by using your textbook. Then we'll move towards next part of this lesson, that is converse. Now converse is nothing but interchanging given and to prove. And this will be given and this will be to prove, but will not prove converse. We'll write just statement of converse, we'll draw diagram, and we'll write just given and to prove. By interchanging given and to prove, we'll get converse of this statement. Now what will be statement of converse? Converse of basic proportionality theorem. If a line divides two sides or any two sides of a triangle in proportion, then it is parallel to the third side. Then it is parallel to the third side. This is given and this is to prove. In previous theorem or in BPT, line is parallel is given and we have to prove sides are in proportion. Now in converse, sides are in proportion which is given, and we have to prove line is parallel. This how will be the diagram? Same triangle, so suppose triangle ABC. Triangle ABC, and there is one line here but which is not parallel to side BC, or which is not given as parallel to side BC. Simply line L which intersects side AB at P, side AC at Q, and what is given now? That is, this is given AP upon PB is equal to AQ upon QC, which is given in triangle ABC. A line divides two sides of a triangle in proportion, that is AP upon PB is equal to AQ upon QC. This is given, and what is to prove? And what is to prove? That line L is parallel to side BC. To prove line L is parallel to side BC, or third side of triangle, that is side BC. See once again converse, if a line divides any two sides of a triangle in proportion or same proportion, then that line is parallel to the third side. First two sides we have taken as AB and AC, therefore third side will be obviously BC. This is about converse. If these ratios are same, then that line is parallel to that side or third side. This is about converse. Now we'll move towards examples on BPT and its converse. Start with example number 1. One figure is given. Suppose triangle PQR, and one segment is given here. Suppose ST, and some values are given, that is in triangle PQR. This is question. In triangle PQR, suppose ST is parallel to QR, which is given. ST is parallel to a segment, ST is parallel to segment QR. Some values are given, that is SQ is equal to 4.8 centimeter, PS is equal to 3.2 centimeter, TR is equal to 5.7 centimeter, and the question is we have to find PT. Find PT. See, in this triangle some values are given, that is SQ is given as 4.8, PS is given as 3.2, TR is given as 5.7, and we have to find PT. And what is given? ST is parallel to side QR, means a line or a segment which is parallel to third side of one side of triangle. Then that segment or then that line divides the other two sides in proportion by using basic proportionality theorem. We can solve this as by using, you don't have to write basic proportionality theorem this whole verse like this. We can use BPT in short like this. By using BPT, if a line divides one side of a triangle, if a line is parallel to one side of a triangle, then that line divides other two sides in proportion or same proportion, means we can write here PS upon SQ is equal to PT upon TR. By using BPT we can write PS upon SQ, this is possible only if this is parallel to that side or one side. PS upon SQ is equal to PT upon TR. Very simple. We have written a reason here, therefore no need to write reason again here. Simply put values of these segments. PS is given, that is 3.2 upon SQ is given as 4.8 is equal to PT. We have to find, write it as it is. TR is given as 5.7. Simple calculation is there. Take this 5.7 which is divided, it will become multiplied to this term. Therefore, we can write 3.2 upon 4.8 into 5.7 is equal to PT. We can write this 3.2 and 4.8 as 32 by 48 into 5.7 as it is equal to PT. 16 2s are 16 3s are. We can divide 5.7 by 3, that is 1.9 into 2. Simple calculation, you can do your own also. PT is equal to 1.9 into 2, that is 3.8 centimeter. 3.8 centimeter. See once again. In this example, segments ST is parallel to side of the triangle QR, and three values are given and we have to find fourth value or fourth segment, that is PT. Means these three values are given and we have to find PT. By using BPT, since ST is parallel to QR, we can use BPT, that is basic proportionality theorem. We can write ratios are same or sides are in proportion or segments are in proportion, that is PS upon SQ is equal to PT upon TR. Putting values and simple calculation by using calculation or doing calculation, will get PT as 3.8 centimeter. Take screenshot of this and write it in your notebook. Then we will move towards next example. Okay, now we'll move towards practice set 1.2. Practice set 1.2 will start with example number 2. Example number 1 is excluded from your syllabus. Practice set 1.2. Some theorems are also excluded. It is angle bisector property of three parallel lines. These are excluded for this year. Practice set 1.2, example number 2. One diagram is given, that is one triangle is given. That is triangle PRQ, and one segment is given here which is, I think, not parallel. We have to prove it as parallel. It is segment NM, and some values are given, that is PM is given as 15, PM is equal to 15, PQ is 25, PR is 20, and NR is equal to 8. State whether line NM is parallel to side RQ. State whether line NM parallel to side RQ. Give reason. Some values are given, PM is 12, 15, PQ and so on, and we have to check side NM or segment NM is parallel to side RQ or not. And to check this, we have to use converse of BPT. Means if two ratios are same, then it will be parallel to that side. Means if you can show Pn upon Nr is equal to Pm upon Mq. Means if these two ratios will be same, if these two ratios are same, then these two segments will be, or Nm will be parallel to Rq. Please wait. I think you can see now. Some values are given, that is Pm is 15, Pq is 25. Pm is 15 and Pq is 25. Pq is 25. Mq is not given directly. Pm is given and Pq is given. First we have to find Mq by subtraction of Pm and Pq. This we can write Mq is equal to solution. Mq is equal to Pq minus Pm. Pq minus Pm, that is equal to, Pq is given as 25, Pm is 15, that is 25 minus 15, therefore Mq is equal to 25 minus 15, that is 10. Now similarly Pr is given and Nr is given, but Pn is not given, therefore we can find Pn as, Pn is equal to Pr minus Nr. Therefore, Pn is equal to, Pr is 20 minus Nr is 8. Therefore, Pn is equal to 12. Pn is equal to 12. Means we got all the four segments, that is Pn, Nr, Pm, Mq. Now we'll take force ratio, that is Pn upon Nr separately. Now Pn upon Nr is equal to, don't take these two together, take separately, Pn upon Nr separate and Pm upon Mq separate. Write statement number 1 for this, statement number 2 for this, and if these two statements are same, then that will be parallel to that side by using converse. Pn upon Nr, that is 12 upon Nr is 8. That is 4 3s are 12, 4 2s are 8. Statement number 1, means we got this ratio as 3 upon 2. Now take another ratio, Pm upon Mq. Pm upon Mq is equal to, Pm is 15 and Mq is 10. 5 3s are 15, 5 2s are 10, that is 3 upon 2. Hence from 1 and 2, observe 1 and 2, that is right hand sides of 1 and 2, that is 3 upon 2, 3 upon 2, therefore their left hand sides will be the same, that is Pn upon Nr will be equal to Pm upon Mq. Pn upon Nr is equal to Pm upon Mq. Means we got ratios as same, Pn upon Nr is equal to Pm upon Mq, and since these two ratios are same, therefore by using converse of BPT, we can write, by using converse of BPT we can write line Nm is parallel to side Rq. Line Nm is parallel to side Rq. See once again, there is one triangle given, some values are given, and we have to check this line Nm or segment Nm is parallel to that side of triangle or not. some values are not given that we have calculated, that is mq is equal to pq minus pm, that is 10, pn is equal to pr minus nr, that is 12, and by taking this ratio and this ratio separately, that is pn upon nr, we got this value as 3 by 2, pm upon mq, we got this value as 3 upon 2. Statement number 1 and 2 both are having same right hand side, therefore their left hand sides will be same, that is pn upon nr is equal to pm upon mq. Hence by using, since ratios are same, then by using converse of BPT we can write segment NM is parallel to side RQ. Remaining examples you have to solve your own or will solve tomorrow. We'll stop here and we'll take a live class again tomorrow at 7:30 am. Thank you.